So today we are back working on the self-powering heater project. Firstly, I would very much like to thank everybody in our community who left a comment or a suggestion on the previous video, because they were all very helpful. There's some very clever people in our community and I'm very proud to have them in our community. A lot of the suggestions and comments were that this will not work. And it may not work. I don't know yet. I don't want to... I know I should have an idea of what's going to happen, and I kind of do. I know it's probably not going to work. By not work, I mean, at this stage, it probably will not output enough power to self-power the heater. Because at the moment, where are they? I've lost them already. We are only using 3 of the TEGs. Because these TEGs were lent to us for experimentation purposes, because they are £100 each. So there's £300 worth of TEGs. So they're expensive. So it's not like we can go out and buy, well, not really, you can buy like 10 of them to experiment with. But we've got 3, and 3's a start. So I didn't film it because I'm not very good at welding aluminium, and I kind of needed to concentrate on what I was doing and not worry about camera shots. So I've made a little aluminium box. I've made a hole here for the exhaust pipe to go into, because I cannot find any 24mm aluminium pipe that I could weld on and stick out and, you know, slide the exhaust over the end and clamp it on and thing it. So if anyone knows where any 24mm outer diameter aluminium pipe is, please leave a comment and let me know so that I can buy some. So I've made this aluminium box. On the inside, can you see inside? I've put in a little plate to just kind of deflect some of the exhaust coming in, because obviously it's going to come in here, and I don't want it to all hit this one square dead on the middle. So I've put a kind of deflector plate to try and help spread it out, hopefully, and that'll do some of that. This is the surface I'm going to put TEGs on. So I've ground it and used various grits of sandpaper, and then a Autosol polished it to try and get and it's now covered in dirty fingerprints again. But it's not mirror finished, but it's nice and flat. Well, not flat, it's probably not very flat either, but it's shiny, I'll give it that. The rest of it it's not bad. I mean, here's my problem with welding. So sometimes I'll get, look at that, look at them lovely welds. Sometimes I'll get them, and then sometimes I'll get them. Like, it's, I need more practice, which is good. Even if this project turns into purely an aluminium, that was me trying to weld a gap. I had ended up with a huge gap at one corner, and I just kind of had to go over and over and over again. Anyway, if all I end up with is aluminium welding practice out of this, actually I'll be happy with that. So I've got exhaust coming in, and for the meantime, I'm not worried about sort of how it goes out. So I've just put a hole in this corner, a hole in this corner, and the workshop extractor fan's just turned on. I don't know if you can hear it. I'll turn it off though. So we'll have the exhaust come in. Hopefully most of it the hot gas will smash into this side where our TEGs will be, rattle about inside, and then exit through this hole and this hole into the workshop for the time being. I'm not bothered about building a manifold or anything like that to capture the exhaust and have it leave. We can worry about that depending on what results we get. So all we have to do now is tidy all of this shit up and set a heater down, set that on, attach this to the front of that somehow, plumb in the cooler, and we're pretty much ready to run and see what voltage we get out of these things. So let's tidy up. Right, we have managed to tidy away most of the stuff. I've got the heater setting, just about ready. Although to be fair, I really haven't plugged anything in. Okay, I'll need to plug anything in. The Bobble Van's water heater is now sitting at the front, going to be a water cooler. I've got a tank of water here, and I think now I'm going to put the TEGs and the water block onto the heat sink. Well, I'm just thinking now, perhaps I should solder these connections together first, or do I just use connector block things? I think we'll just use connector block things in the meantime. Let me join these together, then I'll bring you back and we'll we will clamp this TEG unit onto the body using these 4-inch clamps, gently snugged up with the thermal paste in between, and then we will plumb it in and we'll get ready to fire it up. Right, let us carefully remove the insulating tape. Bit of cleaning stuff. Right, I want these facing that way, like that. Yeah, we'll just run the pipes around the back. I'd rather have the wires at the top where I can get to them. So we'll set you there, gently. Some thermal grease, maybe. Hello. Thank you. And some thermal grease, some thermal grease, some thermal grease. And we will spread it about a little bit because you really want it as thin as possible. Actually, what I'd really like is a plastic spatula. Do I have a plastic spatula? No. Oh well then. We'll just use savage fingers and try and spread it as thin as possible. And why yes, before one asks, I have seen the Tech Ingredients video where it makes its own thermal compounds, and it's really interesting. And I'm not saying I'll try it, but if they start selling their own thermal compounds, I might purchase some of their, because their thermal adhesive is supposed to, well, it's the best thermal adhesive you can get, basically. You know, if we ever decide to install this, put far too much thermal grease on here. In the case of thermal grease, more is not better. Right. We'll put that there, like that. Such as. Hopefully that's a nice flat surface and it'll bond on, not bond on, but you know what I mean, bed in. Oh, great. Well, looking at how little contact surface it's actually making at the moment, it's right, can I do this without dropping off again? Lie still, please. Put that one on there. Okay, sit, there. Right, it's a bit oddly weighted, but it'll have to do. Right, I think I've got some pressure. Hopefully evenly over the surface. Good, okay, right. Now, I'll just probe out the way just now. Do a probe somewhere else. Sit there then. We need to set this on the end of the exhaust. Okay, right, exhaust into our box. Exhaust will come out of the box. Now we just need to connect up some water pipes. Oh wait, you can't see most of what I've been talking about. That's what you get for kicking the tripod out of the way. There, right. Heater, exhausted thing, pumps, pipe, bit of pipe. Because we now have to connect the outlet of the water chiller to the inlet of the cooler things, which is down here somewhere. It's about that much. Please let that be about half. As we'll just cut it absolutely in half. Kick tripod again, apologise. Right, stage one will now be to bleed all of the air out of the system. Red, black, and pick the water tank up to run the water into it. Here we go. Round one, round two, round block, back to tank. Lovely. We've got water. I mean, literally we're ready to turn it on. What else should I check? Well, let's get the temperature probe for the interior of the core temperature, the heater core, the burn chamber. Let's go and get a thermometer and we'll put a thermometer in that. Fuck it, and then let's turn it on. We are almost ready to begin. I have the multimeter connected to the 3 TEGs in series. We're currently got negative 2.1 millivolts because imagine the water is currently hotter than the aluminium at the moment, and the core temperature of here is 20 degrees because it's not on. So let's turn it on. The heater is on. I will bring you back when it's firing. Okay, our heater is lit. Burn chamber temperature coming up. You see, this is now long, I'll show you. Burn chamber temperature increasing. Excellent. Let's see if our, well, the voltage is changing. I'll give it that. I've also hastily sprayed a black mark on here so we can do a temperature check of that bit. Currently says 20. Water temperature, 20.8. So unless the exhaust is falling off inside, which is not, it's not falling off inside. Alright, we're coming up to, if I set this to maximum power. Set to maximum power, excellent. Glow plug still hasn't gone off, it's not going to maximum power run. I'm going to turn the workshop extractor fan back on. We have been running now for 25 minutes. You can see here we've got 4 volts out of the thing. Core temperature is 960 degrees in there, which is absolutely normal. The temperature of this box though, 70, 80, 83, 84, 87, 90-ish degrees. I thought this box would have been hotter to be fair. But then again, it's completely uninsulated and somebody put massive big clamps on it. So they're absolutely adding as, not adding, they're becoming heat sinks. So we're still to better insulate that. In the meantime, I have added some wires to this DC to DC converter box. And purely out of curiosity, I'm going to plug it in and see what reading or something it gets. You please to sit there, thank you. Actually, turn you off. Positive in the hole and well, apart from making the screen flash every now and again, I guess 4 volts isn't enough to turn this bad boy on. How sad. I'm also being slightly... Wait, you're nowhere near the CO2, so it must have been my microphone setting off, because if I take a CO2 reading, start moving, practically 0. In fact, it is 0. I got a different reading a minute ago. There. What I mean is we're not over fueling at the moment either. You could probably actually do with getting the fuel turned up a little bit, if that would help any. But yeah, what are you going to do with 4 volts? Exactly. Not a lot at the moment. So, let's see, we are getting 4 volts, sometimes, there we go, 4.2 volts from 3 TEGs at £100 each. And the water temperature, just for those curious, we started at 20.8, we are currently at 26 degrees, oh, 25.9, 26 degrees. So the water block's doing its job, it's still nice and cool. Our aluminium blocks not blocker, box, aluminium box. 85, 80, 88, 89, 90. So that's continuing to get hotter and hotter and hotter. So I think for our next video, we need to investigate insulating this box a lot better. What can we get that's, you know, flat, easy to work with, doesn't make me itchy, and has good, well, not thermal properties. We want the opposite of thermal properties. We want terrible thermal properties. We want it to be an insulator. What's got brilliant insulating properties? Oh, let me turn this off. Hush. Hush. Well, what can we say about that then? What did we get? 4 and a bit volts? 4 and a bit volts from 3. And this setup, we can turn you off. Otherwise I will forget and come back to things with flat batteries. Yes, next step I think is insulation. We need to get this box a lot hotter. I mean, I could touch it when it was running. It was only 70 degrees. I can't do that with the steel exhaust. I mean, if you touch the steel exhaust pipe coming out the heater, you go and you've left skin behind. So this aluminium box is managing to radiate out a lot more heat than I actually expected. I didn't expect it to be granted, I know they do make heat sinks and things out of aluminium for this purpose, but I didn't expect it to be as bad as it did, okay? So I need, in the comments, please, suggestions on what insulative material I can use, preferably in board form, or as a material that I can wrap. Board would be better because I can just cut it to lengths and slots and fit it round it and make it fit and keep the air in that way and still be able to use my clamps. Also, if anyone has any other suggestions how to clamp them onto there, although to be fair, I could use, once it's insulated, I could use cable ties. Cable ties would work as well. That would remove some of the thermal mass here. Yeah, okay, and any other comments, thoughts, suggestions, please leave them in the comments. And I think for today that will do us, and we will revisit it with a bit more insulation and any other things people say. And I've got a lot more aluminum. We've got more aluminium so we can make more exhaust boxes if we decide to change our design. Another one of the designs I thought about was perhaps getting a bit of pipe, not this pipe because it's too small, and perhaps either cutting out or building on the side a flat section that you could put TEGs, and then inside you could have the exhaust come in at the bottom on a, even better if I was in shot, come in at the bottom on a very shallow angle, so the exhaust gas has to come in and do a swirl over the TEG modules, and then it could exit out either end. You know, you could start it at this end and it would have to swirl its way along the exhausts and then have the same kind of exit on the other side, and hopefully it wouldn't just go in and straight down, but it might do a bit of a swirl. That might help. Hey, we could try that later on if my aluminium welding gets any better. I don't think it will, but we can but dream. So yeah, no, well, to be fair, if we got 4 volts from 3 modules, all we need is another 9 modules, and that would get us like 12 volts, and we don't have to spend like £1,000. More than £1,000. It would cost us. It would cost £1,000 for the next 9 bits. You'd be like £1,500 altogether in TEGs to generate. Oh, I did look at the current draw while it was running. So all together, this whole contraption, water pump, everything, all of this was still just pulling 5 amps at 14 volts. So, you know, 56 watts of So we only have to generate like 50 watts of power. Still not super confident that that's going to happen either, but yeah, we've got this far. Next stage, insulation, and thanks for watching.